This is a video from the Exam 3 review in linear algebra. Let's take a look at 7. Let the set of continuous functions on the interval from 0 to 1 have the integral inner product, and it's the inner product of p and q is the integral from 0 to 1 of p of x times q of x dx. Let p of x equal x squared minus x and q of x equal x plus 1. Find the angle between vectors p and q. Recall, cosine of theta is the inner product of p and q divided by the norm of p times the norm of q. Okay? From here, let's take the inner product of p and q. That's the integral from 0 to 1 of x squared minus x times x plus 1 dx. But that's the integral from 0 to 1 of x cubed plus x squared minus x dx. That's the integral from 0 to 1 of x cubed minus x dx, which is 1/4 x to the 4th minus 1/2 x squared, evaluated from 0 to 1, and that's equal to negative 1/4. From here, let's take the inner product of q and q. That's the integral from 0 to 1 of x plus 1 times x plus 1 dx. But that's the integral from 0 to 1 of x squared plus 2x plus 1 dx, which is 1/3 x cubed plus x squared plus x, evaluated from 0 to 1. That's 1/3 plus 1 plus 1, which is equal to 7/3. But remember, I want the norm of q, and that's going to be the square root of this result. So in other words, the norm of q is the square root of 7/3, and that ends up being square root of 21 divided by 3. The inner product of p and p is the integral from 0 to 1 of x squared minus x times x squared minus x dx. But that's the integral from 0 to 1 of x to the 4th minus 2x cubed plus x squared dx. But that's 1/5 x to the 5th minus 1/2 x to the 4th plus 1/3 x cubed, evaluated from 0 to 1. That's 1/5 minus 1/2 plus 1/3, which is essentially equal to 1/30. But remember that I want the norm of p, which means I have to take the square root of 1/30, which is 1 over the square root of 30, and then if I rationalize the denominator, I get square root of 30 over 30. Now I can put everything together. So cosine of theta is negative 1/4 divided by square root of 30 over 30 times the square root of 21 over 3. And I did a bit of simplification, and I got negative 15 divided by 2 times the square root of 70. Okay? Now, from here, theta is the inverse cosine of negative 15 over 2 square root of 70. And if you pop that in your calculator, you should come up with something like this. Essentially, this is approximately 153.69 degrees. And that's how we do part A. Let's take a look at part B. I want the distance between p and q, but that's the norm of p minus q. Now, to get the norm of p minus q, I have to take the inner product of p minus q and p minus q. But that's the integral from 0 to 1 of x squared minus x minus the quantity x plus 1 times x squared minus x minus the quantity x plus 1. And I claim when you multiply all that out, you're going to get the integral from 0 to 1 of x to the fourth minus 4x cubed plus 2x squared plus 4x plus 1. But that's 1/5 x to the fifth minus x to the fourth plus 2/3 x cubed plus 2x squared plus x. And we're evaluating from 0 to 1. Plug that in. So let's go back. Now notice, wherever I see an x, I'm going to pop a 1 in its place, right? And when I do that, I get 1/5 minus 1 plus 2/3 plus 2 plus 1. Okay? The 1's cancel. And so if we come over here, we're going to get 1/5 plus 2/3 plus, essentially 2 over 1. The LCD here is 15, right? And 5 goes into 15 3 times. And so I end up with 3 plus 10 plus 30 divided by 15, which is 43 over 15. And so therefore, the distance between P and Q is going to be the square root of that result, which is the square root of 43 over 15. And that'll do it for exam 3 review, and this is problem number 7. Thank you.